and even he gets embarrassed when we introduce him, but I'll do so. Professor Meva Singh did his BA in English Literature from Punjab. Then he did MA Psychology. Then he did his MPhil from Meerut University, where he was the first person to work on the effect of lobectomy, so removal of temporal lobe, on monkeys in wildlife biologist. He is one of the two persons who fight for the title. He doesn't fight, but in metaphorically I'm saying, as the father of Indian wildlife. One is Jansen Singh, and the second one is Meva Singh. He is real Singh. Jansen Singh is not real Singh. He is member of all academies, scientific academies in our country, plus psychology, most coveted person. He superannuated God, how many years ago, but is still not superannuated because he gets most money than I have got in 5 years to do research. He has the lab around Western Ghats. There are still 20 people working with him.
Don't feed into my speaking time.
No, I don't know. Your speaking time has not still started. But apart from that, he is a poet, Urdu poetry. When the foreign faculty get over jet lag, then he will treat him with his verses. Apart from that, and it is his sentence, it's easy to become a scientist, but very difficult to become a human being. So he's a great human being, great person, great scientist, and great friend. So Meva, it is, you can bore us as much as you want.
Thank you, Vinod. Good evening, friends. You see, I'm an odd man out. So we started Chrono School sometime in 2002, I think.
Yeah.
And I have been in almost all the chronobiology schools without ever speaking about chronobiology and without knowing anything about chronobiology. I have no idea what chronobiology is. But all these schools I have always been teaching most of the time statistical models, data analysis, research designs, then mathematical models of natural selection, mathematical models of kin selection and group selection, evolution, population genetics, teaching all these kinds of things, and then giving public talks, sometimes on wildlife conservation strategies in India, sometimes on evolution of social systems, and today something different. But anyway, I hope I won't bore you people because I have some interesting stuff to show to you. Let me just start with the first slide. See, just a couple of weeks ago in Trends in Ecology and Evolution, there was this article published which I liked. Just want to read a few lines which are very interesting. See, plasticity-led evolution is central to evolutionary theory. And then we document, the authors say in this article, we document abundant evidence of plastic behavioral changes in urban animals, including learning, contextual, developmental, and transgenerational plasticities, to incorporate behavioral plasticity more formally into urban evolutionary research. Something is becoming a hot topic nowadays, and a new word has been coined called urban ecology. And you can see these are books published in the last 5 years. Okay, something, people think that this is something very new. Urban ecology, how urban environment has influenced the lives of animals. So look at the number of books which have been published in the last 5 years. And two journals have started, Journal of Urban Ecology and Urban Ecosystems. So a lot of stuff being talked about, but I want to take you back 60 years or so. Very unfortunate, the person who started urban ecology research, who should be called father of urban ecology, was a person born in a village called Chhajapur, very close to Lucknow, on Lucknow-Aligarh Road. A person of this place. And this man, his name was Narsingh. So Professor Narsingh was professor of psychology at Punjab University, Chandigarh. This person was working on monkeys. He used to go to Aligarh town, which was close to his village that time. He used to watch monkeys in urban areas, and he used to go to Shivaliks and look at the monkeys in forest areas. So he just started looking at those monkeys and then found some very fundamental differences between the same species of monkeys. And then he started trapping these monkeys. And he would trap these monkeys, bring them to laboratory at Punjab University, Chandigarh, where he designed a series of experiments in those monkeys. And I don't want to go to the details of those experiments, but those days, very prominent journals, these are not just some unknown journals, where he published in 1960s, comparing urban monkeys with forest monkeys, and how they react to novel stimuli, for example, stimuli in novel situations, visual curiosity behavior, social interactions, problem solving activities, number of things he compared. He would put, for example, he had a cage, big cage, just to see dominance. He would put one urban monkey from one side, one forest monkey. They were deprived of food for 48 hours. The food is kept in the middle. Now you see the urban monkey and forest monkey. Immediately the forest monkey, like a tribal fellow, will go and sit like in one corner, and the urban monkey, like we dadas, he'll come and dominate everything, take all the food. I mean, it's one of the things, but he designed very complex experiments, published a series of articles. And these articles became so popular and so famous that none other than Scientific American, as you know, Scientific American, you hardly ever submit your articles. Scientific American solicits. I mean, people who are highly established, well established in the field, Scientific American asks or invites articles, and Professor STC was invited by Scientific American. The only person who has published, it's not Science, it's Scientific American. The only person from India who published in Scientific American way back in 1969. So you can imagine this, that the title of this article was Urban Monkeys. But we are talking of urban ecology, why I wanted to say. And the subtitle was, look, this is very interesting subtitle. In India, rhesus monkeys have shared cities with man for centuries. Has this urban way of life affected their behavior and their ability to solve problems? So in just one slide, I would put most of the findings of Professor S.D. Singh. Urban monkeys were more active and manipulated the objects more than the forest monkeys. Simple. They were more responsive to stimuli of higher complexity values. Then they were far more aggressive, the urban monkeys, whereas the forest monkeys were more involved in grooming and socio-positive activities, what we call. However, when they were tested for their basic intelligence or problem solving, Professor S.D. Singh in his experiments did not find any difference in problem solving abilities of the two. So the last lines in the Scientific American article of Professor Singh is, whereas the selection pressures of an urban environment have shaped many new adaptive patterns in urban monkeys, the basic intelligence does not seem to be affected. Professor S.D. Singh left Punjab University, went to US, worked with Professor Harlow in Wisconsin, came back to India and established a new department of psychology laboratory at Merritt University. And that was one of very unique laboratories because there was a private laboratory where monkeys were kept in the lab, where most of the experiments were done on learning and lobectomy. And then he also established a research center on monkeys in forests of Shivalik Hills. Just when you go to Dehradun, what is called today Rajaji National Park. So in the Shivalik Hills forest, he started these studies, series of different kinds of experiments, like even lobectomy. I passed out, I did my degree in psychology in 1973 from Punjab University, Chandigarh. And I went in 1973 and joined Professor S.D. Singh. So I did not work in the laboratory at Merritt. I was there only for a week. And he sent me to the forest. He said, you go to the forest in the Shivaliks and you work only on the forest monkeys. So I started working with Professor Singh in 73, 74. Unfortunately, Professor Singh died young because of some unknown diseases. And this was the experimental work which was done on monkeys. So I left end of 1974, 2 years I was there with Professor Singh. Then I got interested in, because I got more interested in a lot of wildlife because I used to follow elephant herds in the Shivaliks. So I became more interested in animal behavior or behavior in natural settings without any experimental manipulation in monkeys, in elephants, and in large carnivores. So I found Western Ghats in South India to be far more, better ecosystems than lower Shivaliks. So I left, Merritt, and I went to University of Mysore. That's where I did my PhD work. I became assistant professor, now a lifetime professor. The university has given me this funny, this job called lifetime professor. So, 74, I went here, 75, I started my research, but I became a total, complete obligatory wildlife biologist. Absolutely no experimental work. And for decades, for more than 3 decades, nobody did any experimental work on monkeys in India. That was the end with Professor S. D. Singh's research. And I studied large number of mammalian species, mostly monkeys, several species of monkeys and elephants and other animals. But all my research was in forest, and I am a wildlife ecologist. And interestingly, what the work I want to talk about today is not my mainstream research at all. It is just the side research and the publication I would show you. They are not my main publications. What happened a couple of years ago, about just 10 or 11 years ago, some of my students reading Professor S. D. Singh's articles, they again become interested. They said, "Sir, why not start doing the same thing what Professor S. D. Singh did? Why don't we start some experimental work on monkeys, but in the natural habitats?" I said, "Look, I will not catch any monkeys. I will not have the monkeys in my laboratory here, the so-called laboratory which we have, which is my office. I mean, we have no lab." So I said, all work will be done in the field. So all these experiments are done, whatever I will show you, in the field, in their natural habitats only. But now, let me come close to the topic. See, many animals are obligatory forest dwellers. Tigers, for example, is an obligatory forest dweller. And some are obligatory commensal, like house sparrows, passer domestics, for example. They have become totally commensal. But there are some animals, some species, they live in the forest also, but you can find them in non-forest habitats also. Okay, like several species of primates in India. Now, when we were working in these animals, I work in one monkeys, most of my work, but I have worked on several species of different monkeys in India itself, but much more in other places also. We found some very fundamental differences in their natural habitats. Now, you see, for example, the forest monkeys have a model group size. You go and count 50 monkeys, for example, there will be very low small standard deviation. Almost, the lion-tailed monkeys, 14 to 18 animals. The barred monkeys, 22 to 24 animals. But in urban areas, you can have a group of 5. You can have a monkey group in some areas like 150 to 200 monkeys in one group. High standard deviation. This is very interesting thing now is that if you look at the same species I'm talking about, if you look at the urban monkeys, they all, whatever the number there is, they all come to one tree in the night and sleep. I mean, look at the adaptation there, because there is a lack of trees, they all come to one tree and sleep there. The forest monkeys, even if there are only 8 or 10 monkeys in the group, they disperse and sleep in different trees. When there are lots of trees, why some snoring of somebody else? You can just sleep anywhere. So small group also they disperse. But interesting thing is in the morning, these forest monkeys, they disperse and sleep, but they make what we call contact call. They start the contact call. All of them come together, but in the forest they move as a unit. The urban monkeys, they all sleep in one tree, but in the morning they all disperse. And many of them don't even have visual or auditory contact with each other, because their foraging is very different, their habitat is very different. They have to find food somewhere from this shop and some place. They don't even know each other where they are, even if they would come together. So number of these things, we found that there were fundamental differences. But the main difference we found was in their food finding abilities, in foraging abilities. So what my students told me, why don't we specifically look at the foraging abilities of monkeys, compare urban monkeys and forest monkeys. You see, the most important thing in an animal's life is, I'm not talking about the zoo animals, I worked on the zoos also. I have worked on the zoos, for example, several years in Germany. I worked in the zoos in US. I worked in zoos in India. Now, I'm not talking about the zoo animals, but all wild animals, the most important, the reproduction comes later. Everything comes later. The first thing in the morning is, khana kahan milega? Where to find food? The finding food is the most important activity. So if you are looking for example, innovations, emergence of some new things, new phenotypes or new traits in animals, you should be looking at their foraging behavior. And that's where I would show you, that's where most of the innovation monkeys, 14 to 18 animals, the barred monkeys, 22 to 24 animals. But in urban areas, you can have a group of 5, you can have a monkey group in some areas like 150 to 200 monkeys. in one group. High standard deviation. This is very interesting thing now is that if you look at the same species I'm talking about, if you look at the urban monkeys, they all, whatever the number there is, they all come to one sleep at one tree in the night and sleep. Now, if you look at the adaptation there, because there is a lack of trees, they all come to one tree and sleep there. The forest monkeys, even if there are only 8 or 10 monkeys in the group, they disperse and sleep in different trees. When there are lots of trees, why snoring of somebody else? You can just sleep anywhere. So small group also they disperse. But interesting thing is in the morning, these forest monkeys they disperse and sleep, but they make what we call contact call. They start the contact call. All of them come together, but in the forest they move as a unit. The urban monkeys they all sleep in one tree, but in the morning they all disperse. And many of them don't even have visual or auditory contact with each other because their foraging is very different, their habitat is very different. They have to find food somewhere from this shop and some place. They don't even know each other where they are, even if they would come together. So number of these things, we found that there were fundamental differences. But the main difference we found was in their food finding abilities, in foraging abilities. So what my students told me, why don't we specifically look at the foraging abilities of monkeys, compare urban monkeys and forest monkeys. You see, the most important thing in an animal's life is, I'm not talking about the zoo animals, I worked on the zoos also. I have worked on the zoos, for example, several years in Germany. I worked in the zoos in US. I worked in zoos in India. I'm not talking about the zoo animals, but all wild animals, the most important, the reproduction comes later. Everything comes later. The first thing in the morning is, khana kahan milega? Where to find food? The finding food is the most important activity. So if we are looking for example, innovations, emergence of some new things, new phenotypes or new traits in animals, you should be looking at their foraging behavior. And that's where I would show you, that's where most of the innovations are raised. In urban areas, look at the whole monkeys. Second thing here. Say the monkeys which are living in urban areas, you think that they have abundant food, they don't. I mean, look at the way the monkey has to steal a food. The monkey sitting there, some shopkeeper fellow with a BD shop that's bananas handy. I mean, look at the cognitive skills of these monkeys sits. And even turning side turning of that fellow in the shop, the monkey would run and pick up the banana. The dogs are. So, the urban monkeys actually face very, very hostile environment. And they also depend heavily on, I have put in inverted commas, in our language, they steal food. In their language, they are simply foraging. Poor fellows are just finding the food. But mostly they steal food. Now the crux of my talk is going to be on this. The next three sentences, many food items which the monkeys are dependent on, they are embedded. They are encased. Unlike the food in the forest. Most of the package, for example, you look at the number of packages the monkeys have to open to get the food. So most of the time the food is encased and packaged and embedded. Now this requires, unlike the forest monkeys, this requires extraction. The food is not directly available. They have to extract the food from these encased packages, etc. For example, and sometimes they get cooked food or but I would show something. So some food requires processing also. So unlike in forest areas, these urban monkeys require these basically two processes. One is food extraction and second is food processing. This is what I would be talking about. And then this requires new adaptations. This requires new adaptations, and as a result, the emergence, or I would even call the evolution of new skills or novel ways of finding food. Now I work on many species, but in my talk on this species is not in mainland India and not even all the Andaman and Nicobar Islands. Of the whole 62 islands down south in Nicobar, only in 3 islands we found. Way back we started our work on these monkeys, and we found monkeys only in these 3 islands: Great Nicobar, Little Nicobar, and Kachcha. And only these 3 are unconnected islands, and that's where these monkeys are. So we got interested in this species because it's very unique living there. I mean, it's one of the subspecies. The long-tailed macaque actually is found in Malaysia, Indonesia. But there are different subspecies. This is different one. So in India, this is not in the mainland India.
Sir, in Sundarban I have seen the monkeys.
There are monkeys in Sundarban. There are rhesus monkeys,
They
monkeys,
are
and
non-vegetarian monkeys.
Huh?
They they are non-vegetarian monkeys.
Yeah.
Not available of fruits in Sundarban.
Oh, there are some monkeys where 20% food is non-vegetarian. They eat, we have seen the lion-tailed monkeys eat squirrels. They have eaten, they eat frogs, frog eggs. Because the monkey species which are totally dependent on the fruit, I mean, you have rich carbohydrate food available, but no protein. So, depends on what kind of male food there is. So, such animals require some animal diet to supplement protein. So, these monkeys, this is very interesting thing in these monkeys we have found is that some monkey groups there in the Nicobar Islands, they have become dependent on coconut. Now, why we got suddenly interested is, imagine if I give you know what coconut is, right? We have different, we call phenophase 1, phenophase 2, phenophase 3, depending upon the ripeness, etc. That is for our research work. I phenophase 6, I call the fully grown coconut. I give it to you, okay? Tell you, don't use knife. Don't give it to one fellow who will use katti and cut it and give it to you, okay? Try to get the water or the eatable part out of it. What would you do? With your nails, with your teeth, you will spend half day probably doing this. Okay, so imagine how difficult it is to extract the food. So we became interested to study the coconut processing in these Nicobar monkeys. See, this is, it provided me a sort of an experimental situation there. See, for centuries, certain there are two tribes living there. One is Nicobaris and another is Shompen. Some of the Car Nicobaris, they were living close to the coastal area, and they have been growing coconut for hundreds of years. And there are a couple of monkey groups living there. So these monkey groups have been dependent on these coconuts for a long time. So they have been exposed to coconut for a very long time. And then in 1960s, Government of India started rehabilitation of those islands. Very stupid thing to do. Anyway, who went there? Punjabis and Bengalis. These islands are filled with Joginder Singh Nagar, Karminder Singh Nagar. I mean, all these things are established there. So people basically from Punjab and Bengal, but most ex-army people, they were given land there. So in 1960s, some mainland people were given allotted lands, they went there, and they opened more forests, and they also started cultivation. So some more groups of monkeys became exposed to coconut. Then there was a massive tsunami in 2004, and it destroyed a lot of coastal habitats. Okay, and that was the first thing what we studied. We started the work before tsunami, and then we continued it after tsunami. And it destroyed several more monkey groups from the forest. They moved towards plantations. But there are a lot of forest groups now which are still in the forest. So I have a sort of an experimental situation which you people have to create in the laboratory. I have right there. Monkey groups exposed for hundreds of years, for at least around 60 years, for 10-15 years, and not exposed at all. So just to study familiarity in these monkeys, what we did, we know most sleeping trees where the monkeys sleep. Not same place every day, but we know where there are only a couple of places they would sleep even. Just to see how familiar these animals are with the coconut. Just a baseline data. So these were two forest groups. So these two were forest groups, group 3, group 4, and you can see these forest groups. The coconuts were lying there. One is the inner portion, right one, and one is the regular coconut, green one. And these animals simply wouldn't even look at them. There were a couple of pigs and stuff lying there. They picked up those fruits, but they didn't even look at coconuts. And then, okay, now these are the forest monkeys totally unable to do all these kinds of these behaviors. So these animals have picked up. First of all, can they do it on sand? Can they do it on leaves? They have to find an animal. They have to find out an appropriate place where they can take this coconut and break it. So you look at the kind of cognitive processes which would be involved in these kinds of behaviors, where they have to take the coconut and break it like the way we would do, exactly the way we would use this. And then sometimes these coconuts have thorns or mud around it. Okay, so what these monkeys have developed a behavior which we call typical tool use. What is a tool use? Using external object, not for the purpose it was made, used for something else. Now, you look at these monkeys. They take leaves. They will take leaves, twigs. Okay, wrap it around. Okay, so this is a typical tool use behavior. They are using some objects from the environment which are not directly related to coconut, for example. So to either to cover that mud or thorns, they are using these objects, and not only that, they not only use tools but they make tools. Now you can see this here, for example, all different places. The monkey is breaking a twig, processing it, removing the stuff there, and fourth stage is the one where the monkey is just sort of wrapping it around the coconut. So it is simply not taking something, what you call tool making. I mean, don't ask me tomorrow whether they can make satellites. I mean, I'm talking about monkeys, not talking about ISRO or, this is a typical tool making behavior. And what one fantastic behavior we observed them in them was flossing, teeth cleaning. They would pick up some thick bird feathers or thin wires, or sometimes they'll pick up a piece of cloth, take a thread out of it. Okay, and then they show this very interesting behavior because coconut gets stuck in the teeth. Okay, we published this a couple of years ago, and this article became so popular that Science covered it. Almost the whole thing they reproduced, and in Science, the story was published under the title, "Monkeys may have better dental hygiene than you." So Science picked up this from Journal Primates where we published it, and almost whole thing Science reproduced in as a news item. So this was one very unique behavior. Now the second, I'll come back to these monkeys again, but the second species we work on is the bonnet monkey. It's a commercial monkey in South India. Now we have to do some experimental work on these monkeys, and where we have to provide food for them, because all on foraging. And I am a wildlife biologist. I have permits to work in most forests in South India. I can go anywhere I want, but we are not allowed to, or we ourselves also won't do. We don't offer food to any wild animal, and it's not allowed by law also. So I could not do that. I mean, urban monkeys we work, but forest monkeys I had to get a proxy because we are not allowed to feed forest monkeys. So we selected some monkey groups which are very remote in agricultural areas where they have very little exposure to people. They are basically living on foraging, either on crops or on banyan trees, etc. Very little exposure to people. So that's my proxy for forest monkeys. So it's basically comparing urban and forest monkeys, what I would call now urban and rural monkeys. The rural monkeys are a proxy for the forest monkeys. Now I also want you to know here, people sitting, doing high-class research. See, I work on elephants, I can't help it, trumpeting. I have been whole my life, I am hearing trumpets of elephants, so I also trumpet. So, like how high standard research, which you would see, which is published not in very ordinary journals, quite prestigious journals which we published, and you would see each experiment costed less than 100 rupees. I have used this, except the box here, nothing else, all out of the box thinking. We would sit there, me and my students, we would sit in the nights thinking that we don't want to spend any money. We didn't have much money anyway. So all the money I would pay for research scholars. I'm paying to 5 research scholars. Even now, whatever grants I get, I take all the money for the students. So we started, you would notice from now onwards, the kind of, people would think to do experiments to need millions of rupees, establish laboratories, or, when we started publishing this, those reviewers, what kind of material you people have used, but what kind of results you produced. So what we wanted to do here, the urban monkeys and forest monkeys, we wanted to give them food to extract. So we wanted to put the food in an object which is not familiar to both of them. And what? For 36 rupees, I bought this mouse trap. Okay, so give the mouse trap, food. I will use it later also. See, the monkey has to lift it. Okay, so it is bi-manual task. You have to, lift it, hold it, because it snaps back, otherwise it is a spring. Okay, so the food needs little bit of extraction process. So, okay, so you see the way the monkey has to get this food. Okay, so we did number of trials, usual experiment, repeated trials on same animals and number of animals. And when we compare these data, the urban monkeys and forest monkeys, this is very interesting. That rural monkeys, many of them simply ignored it. You can see this white, ignored. Some explored and left it. Many of them attempted and left it. About 30% of them were able to get this food out. On the other hand, urban monkeys, nobody ignored. Everybody would come and pick it up, start exploring it. Everybody did things, and more than 60% were able to get the food out of this, the urban monkeys. And then, the next experiment we thought we would do, where one group is familiar with the object, the other group is not. What else? Great thing my students did. They would buy Coke bottles at my cost, drill a hole, drink the Coke. Okay? And then, but what is important here is the seal is kept intact. So we would just drill a hole, drain the Coke, and put this sweet buttermilk, what we call lassi, the sweet lassi in it. Okay, give it to the monkeys. This was one fantastic experiment. How the monkeys, some monkeys would bite it here, some do there, some try to open it in different ways. And the most efficient way would be that you have to open the seal. First you have to break the seal. Then there is a ring. You have to remove the ring. Then you should open it. Okay, this. Now I want you to look at carefully at this, what this monkey does. Look, the way it puts canine there to break the seal. Okay, remove the ring. And now, exactly the way we do this. Okay, many people think, they ask me, did you train them? I do not train them, this is what they don't naturally do. So this behavior, which we saw in these monkeys, urban monkeys. Okay, look at this now. The urban monkeys, okay, ignoring no one, simply exploring and leaving no one, attempting all of them, and more than 60% of them did this. Almost all of them drank it. But I am talking about the most efficient way of breaking the seal, opening it and opening it fully and drinking it. And more than 60% of the monkeys were able to get this sweet lassi out of this. The rural groups, most of them simply ignored. Few explored, few attempted, not even one was able to take it out. Not even one monkey was successful in taking this out. So you can imagine the difference in the two in extraction of food. Now we repeated this kind of experiments. I won't go to the details of this in Nicobar monkeys. So we have done this again, only the urban monkeys. This is a latch opening, just like the previous one. So we put one box, opening the latch. The monkey opens the latch and takes the coconut out. And the next one which we did was a little more complex. It is a box where there is a glass plate and there is a hole. And it has to align this, move the glass plate, align the two holes to get this food out. Again, no forest monkey ever capable of doing this. And the urban monkeys, after a couple of trials, okay, it removes this, brings the, aligns the two holes and takes the coconut out. Okay, now, this is a very recent work which we have done on food extraction and food processing. So we wanted to get a gradient now. Typical, the urban monkeys which have very high exposure to people and urban foods. And then some semi-urban group which have some level of exposure. And then this rural group which have no exposure to these foods. So we have these different high, medium and low in terms of exposure. One is basically, let's call it urban, semi-urban and rural. These groups. So again, the experiment involved what? Very expensive material. Okay, this is just the latest very expensive material, peanuts. 25 rupees, 25 rupees. Peanuts we purchased. But what we did here was, we took different forms and different chemical states of peanut. So we have the peanut here. native as it is. Okay, then shell, where the shell is removed, and the last where from the seed, even the skin is removed. Okay, so 3 different forms and 3 different states, chemical states, raw, and we used boiled, and we used it roasted, and all these. So you have a perfect 3x3 factorial design. Okay, so did all this repeated trials on these monkeys. First latency of acceptance. The urban monkeys were very quick to accept it. The other monkeys, you can simply see it. The semi-urban monkeys took a little longer, and the rural monkeys took much longer to simply accept the food. And then I will come to this with videos. Yeah, I want to show you something very, very interesting here. The monkeys use different methods. Using mouth to open. All groups open the mouth. You took the, when you give the raw corn, for example, they put it between the teeth, break it. Just the raw peanuts. But using mouth to open. All groups open the mouth. You took the, when you give the raw corn, for example, they put it between the teeth, break it. Just the raw peanuts. How the monkeys remove the skin? The urban monkeys used hands, and the rural monkeys used mouth. They used mostly mouth, and urban monkeys used hands. We also went to the internet and started searching whether these kinds of data are available on some other monkeys. This is vertebrate monkeys from Africa, the same species, feeding on the same tree. Now look, it goes and takes the fruit directly with the mouth. Okay. The same species from the same fruit tree, the urban monkeys, look here, goes and plucks with the hand. Then the Japanese monkeys, see the Japanese monkeys live on certain slopes in the forest. They are very difficult to observe. So what primatologists do, they give them some food there on the seashore. These monkeys come from those islands, from the hills. They spend some time. Okay, now the forest monkeys, there are some couple of groups which are living permanently on the shore. Okay, the forest monkeys, look here, they come from the hills. The food which is given there, look, they are directly putting it with mouth there and eating it, picking it with the mouth. The same species urban monkeys which are living close to people, they look very neatly what they do. Just pick up like this, like we would do. Pick up everything with hands. Just like what we have found in the border macaques. The same we found in these other species. Now I want to show you certain novel methods. What I have been talking about this. See, this is a typical use of mouth only. See, this is that what I told you, roasted, shelled peanut, where they have to remove the skin, which is dark. How they remove? They can remove only by using the mouth. The monkey puts it in the mouth, keeps on struggling between the teeth, okay, and finally spits out their skin. So what we call using only mouth. And other technique the monkeys use is what we call hand and mouth. Okay, it uses hands, takes it there between the teeth. Okay. Now, what will be the better way if I give to you peanut roasted? What will you do to remove the skin? What you said you do like this? The monkey is eligible to get a job of assistant professor. And using 2 hands. There is another smarter one. Okay, why use 2 hands? If you can do the same thing only with 1 hand. It's lying on the ground, no? Do it like this. Done. In a millisecond, the whole thing is done. Just do it on the ground. Why do it by rub between 2 hands? Just rub it there. Okay. Then we gave them the same kind of thing, what we call generalization in learning, or we call categorization. Whether they can use this, those who have learned this technique, whether they can use it for some material which they are not exposed to. No, peanuts they are exposed to because people use peanuts, they keep throwing. Nobody takes peat Nobody will take roasted peas and give it to the monkeys ever. Okay. So what we did now, just to see generalization of learning, we roasted the peas and gave it to these monkeys. Okay. This you can see. This is with the roasted pea. Same thing. Okay. The behavior which they have learned for peanuts. Now something which they have never seen before. They have never seen the roasted peas before. And the same behavior, you know what we call palm rub and rub ground. We simply call this behavior that rubbing between palms and rubbing on ground. And the most interesting thing now you can see in terms of time, efficiency. Okay. This is the most efficient way of doing it because this takes very little time. As compared to the other methods, palm rub and rub ground, it takes very little amount of time, so it's more efficient method. And who uses it? We did with discriminant function analysis, all individuals we analyzed. Now this is a very interesting thing to see. This is eating without processing. Arey kaun karega, chodo, just eat it. You eat it with the skin itself. Okay, not processing at all. Or processing it with mouth only. Processing it with hand and mouth. Or these novel methods that I call palm rub and rub ground. And only the high exposure means the urban monkeys. And two of our monkeys used hand and mouth techniques. You can see the blue there. But all the monkeys here are only the urban monkeys. And the semi-urban and rural monkeys, you can see they are distributed there between the other three techniques. The novel and efficient technique is used only by the urban monkeys. So, till now, I can take another 5-10 minutes, you know?
Yeah, please.
Okay, now, see, this is what we concluded till now, that in many primate species, there are interspecies, intragroup differences in their habitats. This is exposing them to different kinds of selection pressures. So different kinds of selection pressures lead to different kinds of skills, basically the foraging skills. Okay. Now, this Dr. Sinha and Vijay Krishnan, recently in Encyclopedia of Primatology, International Encyclopedia, they wrote something about macaques, and they discussed our work in detail. And I like one sentence which they have written. See, whether these behavioral adaptations are indeed products of inherent phenotypic plasticity or of genetic adaptations, even over the short term, often remain unknown. I have no idea. I mean, if somebody asked me what are they, I would probably go to the level of saying phenotypic plasticity. Whether these animals have acquired genetic basis, whether the selection pressures have been strong enough, we know whether that this would have caused genetic differences. At least at this stage, I cannot say anything about this. Now, what I want to another 5-6 minutes, I want you to this is not these experiments, not these studies, but how these experiments with urban monkeys led us to do something very fantastic. We never thought of those things. Now, only that in the passing, I will not talk about it in detail. So, how working with urban monkeys led to several new experiments and answered several very interesting research questions which just came out of the blue, which we never intended. You know, when we were this Nicobar monkeys back there, they are not exposed to honey. Okay, so we started exposing them to honey, and what we call honey tasting. You know, we were doing coconuts for something else, and there are these cups kept there with honey, and they are open. So these monkeys would go and dip their hands. Okay, use it and eat the honey. The urban monkeys, all of them within 5 or 6 days, first a few juveniles started, then some other monkeys started. In 5 or 6 days, all the monkeys started tasting honey. And the same area was where forest monkeys were also coming. Okay, the forest monkeys never, even if there are several visits there, the forest monkeys never tasted honey. So we started doing something else now further from this, is that we had put the video cameras are put there, for example, you can see how they approach, everything is just recorded. You know, must have heard of chimpanzees, what is called termite fishing. You know, chimpanzees use sticks. They put saliva on sticks. They put it in the holes to catch ants and termites, because termites get stuck onto the saliva they simply eat them. So they are using external tools to fish. What we call termite fishing or ant fishing. So this is it's stuck over here. Okay. This is just a video I just took it from the internet. See, this termite fishing, how chimpanzees, put these sticks into holes. This is a behavior which was, described by Jain one like Goodall in way back in early 60s. So this is late 60s. This behavior is very well known. So this is what is done by the chimpanzees. Now we wanted to see, हमारे बंदर भी कर लेंगे क्या? Can our monkeys do this? So what we did, we started training these monkeys. Like we picked up certain sticks, we dipped them in honey, and we just spread them around. So after a few days, these monkeys came to know, and they started picking these sticks and they started licking the honey. Okay, so they know that the sticks have the honey. So after several days, then we started putting the honey in bottles where the hand could not go, and these sticks were around. Okay, whether the monkeys could use the sticks. Now this is again my money. You can see this is a breezer bottle. So the students happily buy this kind of stuff. Okay, fill it with honey. Now these monkeys, the figures cannot reach there. Okay. So, and all these sticks are lying around there. Now this was to see whether these monkeys have capability like that of chimpanzees. Not a one monkey would ever do it. They have used the same sticks and they have licked the honey from it. Okay. And they have taken the honey from the bottles before. But now, where their fingers cannot go, now they are not able to use this. And my hypothesis is this. It was never what we call a affordances theory. They were never available like this. Honey was not available in their natural habitats. These sticks were not available like this. They never knew. Give them like this, for example, maybe 1 year, maybe 2 years, maybe next 5 years. If the same thing is kept there, one genius monkey will pick it up one day. One genius monkey will do it. And then slowly, this is the kind of behavior, this is how the innovative behavior spread. They started always by one individual, and then they spread it, like in Japanese monkeys. So they might do it. And I wanted to get one video, my students got it, but it's so difficult. The student have to line in Kachar Island, and he has to first find out where is the motorboat available. It takes 8 hours because there is no internet in Kachar. It takes 8 hours by motorboat to come to Great Nicobar in Campbell Bay. And there the internet availability is intermittent, sometimes WhatsApp and emails you can send. But loaded video, very difficult. So I was hoping till this evening whether I would get it from Mandiman. They have recently now taken a photographical video of a female, monkey female. Look the amount of knowledge which they have. The female almost brings her infant. Takes the infant to the bottle. Okay. The infant has already known this. The infant dips the finger because infant's hand can go inside. Okay. She brings that, she makes that infant, puts the hand, and she immediately catches the hand of that infant. And she licks the now, look at this. This kind of, up to this cognitive capacity the monkeys have, that something can be dipped. But what can be dipped is a part of their own body or another organism's body. They still have not gone to that cognitive capacity that they can make use of those sticks, like the chimpanzees can do. So look at the kind of side information and new kind of questions which are we are answering just because we kept looking at these urban monkeys. Now in the last something, again this Coke bottle. Okay. Now these monkeys, because we were giving them repeated trials. Suddenly we observed one day, looking at these, that when these monkeys are opening this, they are using the same hand every day. Some are using left hand, some is opening with the right hand. So repeated trials, that monkey is using the Coke bottle with the right hand. So one day we were just looking at these videos, one night we sat there, thought, why don't we study this handedness in monkeys? Okay. I mean, whether there is handedness, whether there is a laterality. And so that experiment I showed you earlier, that was basically done for this. I'll skip. Okay, what we did was again that mouse trap. Okay, mouse trap without lid. Okay, so we put some food in this, the animal comes. It's a mouse trap there. The animal comes now. Look at this repeatedly. I will show you the videos of this female, she has used the left hand. Notice she just used the left hand to take it. Now we made it a little more complex. We put that lid which has a spring on it. This is a unimanual task, one hand. Now we made it a bimanual task that the monkey has to open it, give the support, hold it, and then use it. And that video you have already seen. So this one, you will see right hand she used the for support, everything happened very quickly, but the food was taken with the left hand only. And then what we did was, we put one rod on this, long enough that the monkey's tail also doesn't touch the ground. It's actually basically designed by me to take the weight of monkeys, even in the forest also. I need to take weights of monkeys, and so this is the equipment we have designed. This vegetable fellows have that electronic thing. So I wrote to the company, Canon company. They made one special one with me for 40 meters. So we have that rod fixed it on it, and top we put this some small cup. The monkeys have to go and get the food there, and we eat their body weight. So it was designed for body weight. So what we did in this was, we put that one rod and we put the food up there. Now the monkey has to do several things. The monkey has to climb. And unlike here the monkey is sitting, the monkey needs physical support. Right? So you will see everything, how quickly this thing is happening. Now this female just climbs up, uses the right hand for support, she is a left-hander, and ultimately uses the left hand to get the food. Now we made it more complex. This was open. So we would use the other one which has spring in it. Now look at the number of things the monkey has to do. Go up there, needs physical support, has to lift the lid, has to hold the lid there, otherwise it will snap back and get the food out. So quickly you see what happens in this. So we started calling these as the preferred hand and the supporting hand, the performing hand and the supporting hand. So complete laterality in these monkeys. Okay, always all the monkeys at individual level, there was a laterality in all the monkeys, not full laterality. In most of the trials, you would see that they use one preferred hand, and we simply analyze the data and published all these different journals at that time. Higher was the laterality, more was the efficiency. Very simple. The efficiency measured in terms of time taken to extract food. So higher was the laterality, higher was the efficiency. And then one day we simply thought, is it true for more fundamental functions? See, limb use involves some kind of cognitive capacities. Would it be true for more involuntary functions? This is some limb use is more kind of a voluntary function. Monkeys don't immediately eat. You must have seen that the monkeys have cheek pouches. They just keep on putting the food with the cheek pouches. And later on, they'll keep on doing like this and take the food out. And they eat. First they fill it. Okay, suddenly we just thought it. Do the right-handers fill the right cheek first? Left-handers fill the left cheek first? Absolutely the same thing you see here. The cheek pouch had the same laterality what they were using. Now, was it true for opening also? Opening also. The same laterality you see. The left-handers fill up the left cheek pouch first and they open the left cheek first. And when I set it to cross one, within 5 days it came, this is very cute article, we are accepting it. So this was to look at whether more involuntary functions also, whether there is a laterality. And the next I think is the last video on this. No, it's one more video. This is just one video that here. Dips the video because infant's hand can go inside. Okay, she brings it, she makes that infant puts the hand and she immediately catches the hand of that infant. And she lifts the now look at this. This kind of up to this cognitive capacity the monkeys have, that something can be dipped. But what can be dipped is a part of their own body or another organism's body. They still have not gone to that type of cognitive capacity that they can make use of those sticks, like the chimpanzees can do. So look at the kind of side information and new kind of questions which are we are answering just because we kept looking at these urban monkeys. Now in the last something, again this Coke bottle. Okay. Now these monkeys, because we were giving them repeated trials, suddenly we observed one day looking at these that when these monkeys are opening this, they are using the same hand every day. Some are using left hand, some is opening with the right hand. So repeated trials, that monkey is using the Coke bottle with the right hand. So one day we were just looking at these videos. One night we sat there, thought, why don't we study this handedness in monkeys? Okay. I mean, whether there is handedness, whether there is a laterality. And so that experiment I showed you earlier, that was basically done for this. I'll skip. Okay, what we did was again that mouse trap. Okay, mouse trap without lid. Okay, so we put some food in this, the animal comes. It's a mouse trap there. The animal comes. Now look at this. Repeatedly I will show you the videos of this female. She has used the left hand. Notice she just used the left hand to take it. Now we made it a little more complex. We put that lid which has a spring on it. This is a unimanual task. One hand. Now we made it a bimanual task that the monkey has to open it, give the support, hold it, and then use it. And that video you have already seen. So this one, you will see right hand she used the first support, everything happened very quickly, but the food was taken with the left hand only. And then what we did was, we put one rod on this, long enough that the monkey's tail also doesn't touch the ground. It's actually basically designed by me to take the weight of monkeys, even in the forest also. I need to take weights of monkeys, and so this is the equipment we have designed. This vegetable fellows have that electronic thing. So I wrote to the company, Canon company. They made one special one with me for 40 meters. So we have that rod fixed it on it, and top we put this some small cup. The monkeys have to go and get the food there, and we read their body weight. So they were designed for body weight. So what we did in this was, we put that one rod and we put the food up there. Now the monkey has to do several things. The monkey has to climb. And unlike here the monkey is sitting, the monkey needs physical support. Right? So you will see everything, how quickly this thing is happening. Now this female just climbs up, uses the right hand for support, she is a left-hander, and ultimately uses the left hand to get the food. Now we made it more complex. This was open. So we would use the other one which has spring in it. Now look at the number of things the monkey has to do. Go up there, needs physical support, has to lift the lid, has to hold the lid there, otherwise it will snap back and get the food out. So quickly you see what happens in this. Okay. So we started calling these as the preferred hand and the supporting hand, the performing hand and the supporting hand. So complete laterality in these monkeys. Okay, always all the monkeys at individual level there was a laterality in all the monkeys, not full laterality. In most of the trials, you would see that they use one preferred hand, and we simply analyze the data and published all these different journals at that time. Higher was the laterality, more was the efficiency. Very simple. The efficiency measured in terms of time taken to extract food. So higher was the laterality, higher was the efficiency. And then one day we simply thought, is it true for more fundamental functions? See, limb use involves some kind of cognitive capacities. Would it be true for more involuntary functions? This is limb use is more kind of a voluntary function. Monkeys don't immediately eat. You must have seen that the monkeys have cheek pouches. They just keep on putting the food, they fill the cheek pouches. And later on, they'll keep on doing like this and take the food out. And they eat. First they fill it. Okay, suddenly we just thought it. Do the right-handers fill the right cheek first? Left-handers fill the left cheek first? Absolutely the same thing you see here. The cheek pouch had the same laterality, hand laterality what they were using. Now, was it true for opening also? Opening also. The same laterality you see. The left-handers fill up the left cheek pouch first and they open the left cheek first. And when I sent it to class 1, within 5 days it came, this is very cute article, we are accepting it. This was to look at whether more involuntary functions also, whether there is a laterality. And the next, I think, is the last video on this. No, it's one more video. This is just one video that here. The monkeys which were left-handers, they did it very quickly when the food was here. And they were struggling when the food was here. The right-handers immediately took the food when it was here. And they were struggling when the food was available on the other side. So in terms of simply latency, we simply compared latency molecular statistics to see that when the preferred hand was permitted, their efficiency was much higher than the non-preferred hand. Okay, so what we did now in this was, this I will not talk in detail. So, because I am fond of mathematics, lot of detailed statistical modeling, so we just wanted to check it mathematically, whether the laterality leads to more efficiency. So we designed a thought experiment where we designed a robot. So ultimately I call it ROB-S, Rob symmetrical. Now this Rob has to move in time and space. It has to pick up objects, but it is in terms of cognitive functions, in terms of brain, in terms of body, it is totally symmetrical. Now it moves somewhere, it is circular movement. It can turn left or it can turn right. It is symmetrical. It can use left hand to pick up something, it can use right hand to pick up something. So ROB-S, I show how the ROB-S would move in time and space and can get into infinite loop. It can go here, it doesn't know it can turn this way. And from here it can turn this way. It can go on loop in that loop, infinite loop. Then at what I call at the boundary condition, I introduce one more ROB, which we call ROB asymmetrical. Now that ROB is asymmetrical, that it develops a tendency either to move left most of the times or use the right hand to pick up objects. Okay. Then we go on comparing their efficiency. And this is a self-learning system. Slowly the system which is symmetrical, it goes on through self-learning, it goes on becoming asymmetrical until the entire system becomes asymmetrical. This was published in Journal of Theoretical Biology. So this is how the thought experiment is. This is a rod which moves around, as I said, you don't bother much about it. So this is how we move this is how ROB-S goes, okay, in loop systems, okay, which becomes totally infinite loops. And this is where I introduce another one, which is ROB-A, which is ROB asymmetrical. So this system now becomes more efficient than the other system. That system keeps on self-learning and different objects, how much time do these two take, and then ROB-S also ultimately becomes, the whole system becomes asymmetrical, because asymmetrical systems functions have far more efficiency. Think in terms of human beings, for example, in terms of cognitive processes. If you are using both hands equally, okay, the time taken, whether not to do something, okay, whether to use left hand or right hand, but if you are using, say you are a left hander, immediately you would do this. To pick up objects, anything, if you are asymmetrical, the time taken is much lesser. The cognitive several in class 1, Journal of Theoretical Biology, Third Science, Private Conservation, Behavior. Recently, a few days ago, American Journal of Biological Anthropology. This is where all these articles were published. And you have seen the amount of resources which we have used to conduct all these experiments. Okay, I think this is all what I have to say. And see my lab, again my lab is 10 by 15. That's where I sit. All my labs are, the minimum size I need is 1,000 square kilometers. And the others are much bigger. So these are the, we work on several species, sympathetic primates, flying monkeys, elephants, long-tailed macaques, large mammals, water monkeys, rodents, and bats, slender lorises, new water monkeys, lagoons, dogs, lizards, forest squirrels, great apes also. So all these kind of species, all these people, they have been working for years together. Many of them have got their degrees, and some are almost about to retire. Vinod says, I could never retire. So these are the people who have done most of the work, and when in speaking, I thank them all and thank you very much.
Any questions? Any curiosity question?
put the stick in to get the honey, do you think if they saw a human do it, they would copy?
Nothing, they will have to do it on their own. But if one monkey does it, others would learn.
But not from a human doing it?
Absolutely nothing. See, there was a very well-published research in Japanese monkeys. Japanese people used to give them food to get them out from the hills. Primatologists, from 1940s they started. In Takasakiyama, one island, they were giving them sweet potatoes. And sweet potatoes have a lot of mud. Okay, we also see if there's something muddy, the monkeys go and put it in the water. In one of the groups, there was a monkey female called Imo. And what we call her, Imo the genius. She was a late stage juvenile monkey. She went one day, she picked up this potato, sweet potato, went to the sea. Now the monkeys can, this is seen hundreds of times. The monkeys washing it. What she did there, she took water with one hand and poured it over this and washed it. The behavior which was never seen in monkeys before. Now this was a discovery when we started using the word tradition and culture. The first time we used the words tradition and culture, when Kawai and Kawamura, they published in 1952 this article. So this female did this. Slowly, other juveniles picked up this behavior. After some years, their mothers, the infants and their mothers picked up this behavior. Adult males never did it, as usual. So adult males never learned this behavior. And so this behavior is how it spread. And then one day another thing happened to the same monkey, Imo. They would give this wheat grains. And the grains are lying there in the sand. Like I showed you, the monkeys have to eat and pick up that wheat grains. So they spend a lot of time. So this one day what this female does, Imo, she takes a whole lump of it in two hands, goes to the water, to the sea, throws it. And in seconds, the grains are floating. They just takes one lump, she takes it. And slowly this was called placer mining. So these two behaviors, which were labeled as traditions, cultural traits, which got spread through cultural learning. Again, slowly, the other juveniles and some of their mothers picked up, adult males never did it again. Adult males never learned these behaviors. But, as you said now, on some other island, the people did there, they would do it. They would keep on washing the potatoes in front of monkeys. Okay, never happened. This behavior has never been seen in any of the islands ever. It has remained only in that particular island and happened more than 50, 60 years ago, 70 years ago now, and nowhere else it is seen. All innovative behaviors are by and large the innovation by one individual. And from one individual, it socially and culturally, it spreads in the groups and it's learned whether it's in humans or it's in animals. The story is the same. So it's in humans, of course, we can teach it. But in monkeys, they just learned it socially from even, there is no evidence that the monkeys can actually train their offspring. There is some amount of training which we have seen in carnivores, in birds of prey, for example, hunting. And the females, the birds, the eagles, because they undergo socialization up to 5 to 6 years, they dive along with the mother. And in tigers, for example, the mother, the tigress, sometimes would attack a deer, would not kill it, would what we call incapacitates and the young cubs. They can't make a kill, they are not grown up that much yet. So at certain age, when they are about 7 to 8 months old, the tiger cubs, so she just sits there. The deer is incapacitated, cannot kick anymore. So these cubs come, they start attacking. So they what we call, happiness, menemara, I killed it. I did this, So they learn in the whole process. So, whether we can call it tutoring, but you can see it, there's some kind of, but these kind of things are very, very rare to see. Whether the same thing even can't be taught by one animal to another. I think they simply pick up by observation. So it is simply culturally, it is transmitted by simply observing other animals doing it. And this is what, I have that data in detail. Just now, the day before yesterday, only my student submitted a thesis when he had to explain all this, which animals pick up these behaviors, which juvenile stage, males or females, who picks up these behaviors like this, innovative behaviors. That is much more detailed data. But no, they can never learn from humans. At least there is no evidence till now, ever.
You might have thought the urban monkeys might be more prone to learn things from humans. They're spending so much time.
Pardon?
sorry, urban monkeys, I was thinking might be more prone to learning from humans. They're spending so much time in the company of humans, but not.
See, this is what we are seeing. Otherwise, they would have started picking up knife and opening the coconut. Okay, thankfully they have never done it. Otherwise, they will come people one day. They have to learn everything on their own. And what we call affordance is, those objects and opportunities have to be available there. If they are not simply available, that's what I said. This sticks with the honey and these bottles, if they are there for next 1 year, 2 years, 3 years, 4 years, probably some monkey will pick it up one day. Will dip it like Imo Japanese monkey did it. So some monkey will definitely pick it up one day, not tomorrow, not next year, and dip it in the honey bottle. Then it will probably culturally spread it. But it has to develop like this. We can show it, them doing it like this. Actually, some of my students did it. I discourage doing, telling them, don't do all these kinds of things. They have to do it on their own. But they told me one day, we did it, we tried it. So no, it won't. They won't.
So, thank you.
Yeah.
Right. So the temporal organization of behavior is to try and serve these functions. Now, when you were talking about the monkeys that were sleeping together in urban environments, I wondered whether that behavior is to, avoid, because it's the most vulnerable time.
No, I think it is an adaptation to the lack of trees in urban environment, because there are so few trees. So they have learned now to, in many places there is only one big tree.
But why can't they go and sleep why do they choose to come together?
Because there is no other tree available. Most of the time there is only one tree.
My hypothesis could be that by sleeping together, the risk if some predator or some human or dog or something comes.
I don't think so. I think it's simply an adaptation to the local lack of trees. Because no dogs would climb trees. I mean, in the forest, for example, leopards can climb trees. So it would happen more, should happen more in the forest.
It still is,
the leopards can climb trees.
It still is a
dogs
survival.
don't climb trees. So if that were to be the case, evil people also, by nights nobody goes and disturbs these monkeys.
Similarly, have you seen a shift when the monkeys become urbanized, when the urbanized monkeys, a shift in the timing of their behavior because of the fact that food is available at particular times and predators aren't there at particular times? Because I think they've done those experiments with rats. I mean, you see it in the London Underground, for example, nocturnal animals. If you look down at the railway line, suddenly between the trains, the mice and rats come out, right? And they're foraging for food because they know people are dropping food, even in the middle of the day. And so these they're urbanized rats have altered the timing of their behavior.
Sure, if you see, for example, okay, I don't study circadian rhythms, but I study their behavioral activity profiles.
Mm-hmm.
The forest monkeys, for example, early morning,
Yes.
they're hungry, they first go there and sit for the sun,
Yeah.
a few minutes, and then they start foraging.
Right.
Then up to around 10 or 11 o'clock they forage.
Right.
Then up to 2 o'clock, 3 o'clock, those monkeys sleep. They just groom each other. And in the evening they go for one more round of foraging before they go to sleep.
Right.
Urban monkeys don't have such rhythm at all.
Yes. See, that's
They're the whole day. Because, see, there the food availability it's more predictable. And in urban areas, the food is so unpredictable. They might get a lot of food. People, sometimes we feed them. I used to go, the Delhi University often. So to go to an airport, I would take early morning, the Ridge Road. You go and see. It is illegal. But see the number of cars parked there. So many people come in cars and feed these monkeys. Then whole day they complain also. We tell them don't feed these monkeys because they'll become a nuisance to you people. So it's the rest of the day they complain. So the food could be available a lot. It may not be available the whole day.
There was a famous experiment in the circadian rhythms field, a researcher by the name of Pat DeCourcy. She lesioned an area of the hypothalamus that's responsible for the circadian rhythms, the suprachiasmatic nucleus, I think in chipmunks.
Yeah.
And she released them into they were wild caught, she released them into the wild and she did an experiment. Some were sham lesioned and some were lesioned. And the ones that were lesioned, that lost their temporal organization of their behavior, were more subject to predators because they were, foraging for food and things without.
Obviously, there has to be some underlying mechanism for everything.
Yeah.
Nothing can be there without underlying mechanisms. You see this one quick thing, there is another tool whose behavior fantastic in capuchin monkeys in Brazil. So one of my students, Madhur Mangalam, he went to Brazil. See, there they are using stone tools. They have to break nuts. So what they use is the big stones. They are using them as anvils. And then, what the student of mine, he studied there, he started taking the weight and approximate weight of the monkey, looking at it. And then the stone tool they have used. And then, he saw the coconuts, the nut which they use, Brazil nut. And then he studied biomechanics. From how far they take it, as using as hammers. So the stone tools small stones are used as tools, as hammers. I was just reading on the internet, sitting there. Just now, our article is published in Science by Acknowledge something. Both are, I think, husband wife. Two persons with the same name. And one is archaeologist and one is a paleontologist. And they have written in this article that 50,000 years ago, some stone tools which were found there, which people thought by early American settlers, the Native Americans, had shaped those stones as tools. Now they have given all the evidence these were crafted by monkeys. And just now the article is published in Science that these are crafted by capuchin monkeys. And we know the complex behavior used by capuchin monkeys, stone breaking nuts by using stones.
So a comment and a question. The comment is you said there are no rhythms in monkeys. 25 years ago I was at Anna University. I can tell you during breakfast and lunch, a gang of monkeys would come and descend. Precisely. And not only that, if you had an ice cream, there would be a gang of 10 monkeys that would attack you until you drop it. You can't go, otherwise they will attack you. So, it's interesting to study rhythms, they learn behavior, not rhythms.
See, this attacking behavior, National Geographic took a couple of years to make one movie in Varanasi. See, there is some group of monkeys, they were following this Jain community people. They were taking some cooked food and they go and feed those monkeys. And there are beggar children. So those beggar children would ask for food, they wouldn't give it to them. They would give it to the monkeys. They would give the food and go. And these children go and beat the monkeys and rob the food from those monkeys. Okay, now over the years now, these monkeys became hostile towards individuals or infants of a particular age. Now you are going with your son or your daughter in the morning for walk. If that particular age, the monkeys attack. So now there's a whole hue and cry, trap these monkeys, they are vicious monkeys, they are attacking children. But you look at the origin of that behavior, the genesis of it. How did they develop this behavior? The same thing you urban giving food, whether it's to street dogs or it's especially to monkeys, the species which live in organized groups, they have a hierarchical system. They have very strict dominance hierarchies. Okay, now getting the food is subordinate monkeys can never, see if you keep the food there, between two monkeys, the dominant monkey would slowly walk and pick it up. The subordinate monkey will look at the monkey and, "Maine to dekha hi nahi." I have not even seen it. It just turn the back. So this happens in this kind of thing. If you offer food to a monkey, the monkey considers you the most subordinate organism, because in nature, nobody offers you food. You have to snatch food. You have to get food. Okay, now somebody giving food. In monkey's language, you are the most subordinate animal. Now next time, somebody is walking with bananas, the monkey says, "What a stupid fellow. He's supposed to give it to me. He's a subordinate animal. No, he's not giving." So monkey attacks.
My question was exactly based on that. You were saying that the urban monkeys live under a lot more stress than
aggressive.
The domestic monkeys.
The
the forest monkeys. So are they actually stressed in terms of the cortisol levels?
Oh yes, a lot. This work has been done.
And does that relate into metabolic disorders being more
That I don't
combined with the urban food, which is not healthy, being processed possibly? Does it relate into worse metabolic health and life expectancy?
You are right. What we have started saying that these animals are probably doomed.
Yeah.
Their cortisol levels are very high.
Yeah.
And homeopathy has recently done. We have done work on in the elephants.
Yeah.
Taking samples from wild elephants and from temple elephants.
Yeah.
The temple elephants have such high levels of cortisol.
Yeah.
So all animals with in this captivity or with interacting with humans have much higher levels of stress.
And the peripheral rhythm is going to be completely messed up because there's no time span as to when they're eating, right? They're going to
Yes,
eat all over
right.
the place. The cortisol is everywhere.
Yeah.
So that's going to be great to catch and do some glucose and insulin tolerance. in these two groups of monkeys.
No, we are doing one student of ours is doing though. She is doing it in a place called Tanimala.
Wow.
So we are doing it within the group also.
Yeah.
We are seeing dominant animals, subordinate animals.
Yeah.
That we're taking the hormonal level studies in these monkeys now, and urban monkeys and forest monkeys. Now, she has started the PhD work now.
The other question she's asking is, you mentioned the hierarchical structure, right? It's very well defined in forest monkeys, whereas here, it must be disrupted.
No, it is
because
there
it's there.
both forest and urban monkeys. Hierarchical system is very strict.
And is it based on who gets the spot in the tree? Because they're going to eat at different places without the
Oh, the
observation.
dominant animals, you would see, for example, sleeping in the tree.
Yeah.
The most dominant, what we call the alpha male, you would see always sleeping in a branch where there are at least 3 branches minimum.
Got it.
Or arms, he's sitting like this, and back is there because 3 branches. And the other fellow will be still sitting on one tree, one branch sitting like this, sleeping. So they get best, not only for access to food, they even get the best sleeping places.
But in spite of that, they're going to be even more stressed, right, being the alpha.
This is just fantastic. Who should be more stressed, the dominant and subordinate?
I think the alpha, right? So,
You see, in certain, this will be context specific. The alpha male has to maintain that level of, hierarchical position. So we would expect that he has to have very high level of stress. On the other hand, the subordinate monkeys, now you look at simply this, eye contact. In a monkey, for example, what we call, to you it might look like one monkey attacked another monkey, but not for me. There are, the first stage the monkey does is simply looks at another monkey. The other monkey, if it is subordinate or something, he looks away. No, doesn't move, looks away. Over. Aggression is over. Look at it, look away. And then, suppose nothing happens, then the monkey stares, like people do.
yeah.
Okay, stares. Over. Aggression would not have to go beyond. Most sets, Still nothing happens. Then eyebrows go up. First they look at, then stare, then like this. And then we call, open mouth. Then all will happen very quickly, The monkey just opens mouth. And then nothing happens. Very rare situation because what we call nothing happens, then the monkey actually attacks. What do you think? A monkey attacks another. So we know all these kind of subtle things now. See, looking at another monkey is a threat. Now you look at the, simply think of a social structure of monkeys. I wrote this way back in the, I published this in 1985, Evolution of Consciousness in monkeys. So I didn't call what is consciousness, but I call what a conscious act would be like. This was published in a book in England. See, you look at the subordinate monkey. The subordinate monkey cannot go very close. There is a physical distance maintained from the dominant monkey. The dominant monkey can go anywhere. Okay, the dominant monkey moves in time and space, very free. The subordinate monkey has to maintain that distance from the dominant monkey. He cannot go close. Now, in order to maintain that distance, he has to know how far that monkey is. So he has to look at that monkey. Now, when he looks at that monkey, he is emitting a threat and he gets beaten up. So look at the stressful situation all the time. This animal must look at the dominant monkey to maintain inter-individual distance. But to look at, he is emitting a threat signal and gets beaten up for this. So you look at the amount of stress the subordinate monkeys have. So this is exactly what we are now doing it on routine basis. But context specificity, for example, when the mating season comes, we expect very high level of stress in dominant monkeys. So we are doing it context specificity of stress hormones and routine. So I have these hypotheses in routine. The subordinate animals have very high levels of stress than the dominant animals.
Any other question? No? So if there are no questions, we thank Professor.
It's one evening, nothing will be better than this talk, I'm telling you. So,
ऐसे ही रख लो वैसे मुझे बहुत गर्मी वाले पे
फोटो खींचा जाएगा
Thank you.
Thank you.
well, okay, I must thank you all. Tomorrow, sharp 8:45. 8:45, we
You
should
must be here
for-
because 9 o'clock sharp the lecture would start.
Okay, thank you. See you tomorrow.